Hello friends, today we are going to discuss about steps to design an analog Butterworth low pass filter. The step number 1 is we have to find out the capital N value. Capital N is nothing but order of the filter. Here we are having two types. The first type is they will give the specification as AP, AS, OMP, OMS. AP is pass band attenuation, AS is stop band attenuation, OMP is pass band frequency, OMS is stop band frequency. If the given specification is like this, then we have to use the formula as N should be greater than or equal to log of square root of 10 power 0.1 AS minus 1 divided by 10 power 0.1 AP minus 1, the whole thing divided by log of OMS divided by OP. Sometimes they will give in the form of condition, that is lambda. From that condition we have to find out lambda, epsilon, and they will give the OMP, OMS values also. That will be in the form of condition. If they are given that is type 2, then we have to use the N value as N should be greater than or equal to log of lambda divided by epsilon divided by log of OMS divided by OP. The step number 2 is here we will get the N value as in integer format. Here we have to round off the value and find out the N value. For example, if the N value is 1.523, then round off the value N as 2. If it is 1.1 also, you have to take the highest value, that is 2 only you have to take. Step number 3. Find the transfer function of H of S. Here the order of the filter and the polynomial equation is, if we are calculating N value as 1, then we have to know the H of S value. You should memorize all the values because they will never give the H of S value. We have to find out by calculating the N value. If N is equal to 1, H of S value is 1 divided by S plus 1. If N is equal to 2, H of S is equal to 1 divided by S square plus root 2S plus 1. Most of the problem will comes under N is equal to 2 only. So you have to memorize the H of S value as 1 divided by S square plus root 2S plus 1. N is equal to 3. H of S value is 1 by S square plus S plus 1 into S plus 1. For N is equal to 4, H of S value is 1 by S square plus 0.76537S plus 1 into S square plus 1.8477S plus 1. Next step is calculating the cutoff frequency OMC. The formula is, here we already saw two types. For type 1, OMC is equal to OMP divided by 10 power 0.1 AP minus 1, the whole power 1 by 2N. If they are given in the specification epsilon lambda, that is type 2, then we have to use the formula OMC is equal to OMP divided by epsilon power 1 by N. Step number 5. Here we have to find out the transfer function, that is analog transfer function H suffix A of S, by substituting the value S as S by OMC. This OMC only we calculated in step number 4. Replace the S value as S by OMC and find out the H of S. After that they will specify, they will give the specific value. Either you have to use the Butterworth filter, or that is a bilinear transformation or impulse invariant method. So in this Butterworth filter, choose either bilinear or impulse invariant from the given problem. Thank you.